Since we have a lot to get through, I'll go ahead and get started. So again, welcome to today's webinar. We're going to be talking about what matters in document parsing and how to measure it. This is basically a grand reveal of a new paper that we just released that Antonio is going to be kind enough to walk us through. And there will be actually a link to the paper at the end of the presentation as well. So first, we'll start with some introductions. I am your host today. I'm a principal solutions architect at Unstructured, and we're joined by Antonio, who is a principal data scientist at Unstructured, and he's going to be the one presenting today. The agenda is going to be basically a first introduction about Unstructured, and then we're going to actually go into the presentation, evaluation for document parsing, introducing our score framework, and then finally, some demos and examples from Antonio. And then some quick housekeeping items. So chat goes in the chat. Everyone seems to be familiar with it by now, which is great. By all means, make use of it throughout the presentations. If you have questions or thoughts, feel free to throw those into the chat. If you have specific questions, there is going to be a Q&A at the end. So questions actually have a separate section. So please drop those in the Q&A box. Recordings, we will email you the recording afterwards. And then if you have specific questions that maybe involve more in-depth, sort of one-on-one, we do actually have that ability. So you can basically send us a one-on-one message and we can give you more information after the session. And with that, let's dive into who is Unstructured, and then I'll hand it over to Antonio. Okay, so Unstructured, we started around 3 years ago with an open source library that has reached now over 40 million downloads. And that library was specifically designed to handle unstructured data in all its forms, making it accessible for downstream processing for various use cases. Of course, that also coincided, our sort of launch of that product coincided with the launch of the first generation of large language models. And so RAG became a very common use case for us. So there's a lot of built-in features in that library for the RAG use case. We don't just serve RAG, but that is our most common. Today, we actually have launched a managed ETL platform for working with unstructured data, and we have over 10,000 paying customers on that platform. And with that, let's go ahead and jump into the actual presentation for today. And so today we're going to be talking about evaluation for document parsing and introducing our score framework. So let's go ahead and jump into that. So when we attempt to compare document parsing systems today, we face a fundamental challenge. How do you actually evaluate outputs that look completely different from each other? So what you're seeing here is a perfect example of that. We have the same source document on the left. This is a Lehman Brothers economic report from 2007. But notice how different the various outputs are. So we have 3 different outputs here, each indicated by a blue arrow. On the left, we have a basic text-based output. In the middle, a JSON representation with all kinds of interesting metadata. And on the right, we have an HTML format with divs, tables, and semantic structure. So all of these outputs are, in fact, correct representations of the same document. They contain the same raw content information, but they're all structured completely different and possess different levels of structural and layout information. So this is where traditional evaluation metrics actually break down. If you use standard string matching metrics like edit distance, you either have to pre-process these outputs to conform them all, or you're going to end up heavily penalizing one of these outputs or more than one, simply because the structure differs, even though all are semantically valid. So this isn't just an academic problem. This is in production systems as well. There are often different models, different output requirements. In one use case, you may need sparse HTML. In another, you might need very verbose HTML with metadata included. Or perhaps a new model may prefer to organize table horizontally versus where your ground truth organizes it vertically. So standard metrics are going to fail some of those outputs, giving you misleadingly low scores. So this is exactly why we developed SCORE, to evaluate semantic correctness regardless of structural variations. So let's look at how existing metrics handle this. And with that, I'm going to hand it over to Antonio.
Thank you, Daniel. So hi, everyone. Yes, so Daniel has shown some examples in which the different partition solutions are going to provide different types of outputs. And this poses a challenge when we run evaluation. So in this slide, we can see some of the common evaluation metrics, like word error rate or character error rate or normalized edit distance are going to be looking at the content of the document, so how the text is being extracted and looking at that the text is following the reading order. There are other metrics that are used, like tree edit distance for tables, where we look not only at the text output, but as well how the tables are getting structured, or we can look as well how the different elements in a page have been detected and how they are evaluated using metrics like the IOU, which will look at how the bounding box is detected, perform with a given type of element added to it. So as Daniel already commented, we face some challenges when evaluating systems for which output might be semantically very similar, but syntactically or the way they're being produced are kind of different. And we would like to be able to run properly every solution that we evaluate in a way that we get the best performance and we are not biased by a very strong, a very strict metric. So the idea that we had is that instead of trying to create new metrics, it would be to reuse the existing metrics, but adjust them in a way that we can use them for an effective selection and tuning of document parsing solutions. So this brings to what we have named the SCORE framework. And we are looking at different aspects of the evaluation of document parsing. One of them is, instead of relying on a very strict normalized edit distance, we are allowing for a more soft version that will adjust to the way the content has been extracted. So we can allow for a more soft matching that recognizes better the semantic representation of the content. We've been looking closer at what are the tokens that have been extracted. So trying to find content that is erroneous, but as well, now that we have the large language models, be sure that there are no specific hallucinations coming out of the model, and find a way that we can distinguish both omissions or errors versus hallucinations. Then as well, we've seen that when we evaluate tables, if there are small changes that are produced by the solution, the score might change quite significantly when the error is not that large. So we have been softening the metrics and allowing for these structural variations and allowing for a better scoring of these models. And finally, when we predict a set of elements that compose a page, we assign a type like a title, paragraph. We are allowing as well be aware of the hierarchy of element types that we can have, and be sure that we understand the semantic implications of the different assignments to the element types for the different elements. And this is basically the idea. So it has been available in a paper that has been made available through Arxiv recently, and there will be a link at the end of the webinar, so don't worry about it, but you can already find a reference here below. What I'm going to do now is to show you quickly a couple of examples related to the content and the table structure that will allow you to have a better understanding of this. So this first example is more related to the content, even though we'll see that the content is structured as a table. We can as well try to understand how the text has been extracted and what is the ordering of the text within the example that we have here at the top left. So below we show the ground truth has been annotated, and on the right we show a representation coming in HTML that's been one of model's prediction. So we can align the text that is on the left from the ground truth to the prediction that is on the right. And if we look only at the text and try to apply normalized edit distance based on the reading order that we'll extract from the table, the score is quite low, but we can see that the text is there, and we can align it in a way that we understand that even though it might not follow exactly the ground truth, the output is still correct. So we can adjust the normalized edit distance and still get a reasonable score that better reflects what's being extracted. In this second example, I would like to show something that is a bit more complex related to tables. And in this example, top left, we get a set of information that is organized in columns that has been identified as a table when I'm doing annotation in the ground truth. The main challenge here is to organize the data exactly as it has been identified in the ground truth, because everything has been aligned in a way that we get a defined set of cells, while the prediction that is in HTML has identified different boundaries between the different words that highlight some of the specific information that is as well available in the document. So when we do evaluation of tables, we look at the structure and the content, which is typically done using the tree edit distance, which is a version of the edit distance used for evaluating tables. And we find that just trying to match exactly syntactically how this thing has been extracted, the scores will be lower if we allow for some variations that still account for the semantic content. So with these changes that we have done to the scores, we're able to better rank the different systems that we are evaluating, and being able to ensure that we see the evaluation of the different systems properly. So I have been showing now what the score framework is and a couple of examples, but I would like to show you where the score framework fits in. And for that, I will jump quickly to our platform. So some of you may know that we have a hosted managed platform where we can set up different workflows that will process your data from a given source to a given destination. Your source could be a Google Drive, S3 bucket. You can select from a broad range of different source and destination connectors that we provide. And in between the source and the destination, you will be able to set up the different processing strategies that we have developed. Everything that you see here is as well available through API. So we have a SaaS that allows you to use everything that you will see here. And we'll just want to quickly show you a very simple workflow where we define a source and a destination. As I mentioned before, we define the partitioner or document parsing step, and we can as well have additional set of processing like enrichment for chunking if you're using RAG, or additional enrichments if you want to have descriptions for images. But I wanted to jump quickly to the partitioner. So the partitioner allows you to get a document and that is unstructured, obviously, and then provide a structured version of it. And there are different solutions that we have developed from more simple to more complex ones. And within the solutions that we have developed, there is the VLM, or Visual Language Model, as we call it, where we can use different models that have been available from out there from well-known providers like Anthropic or OpenAI. So what we use the SCORE framework for, and the evaluation system that we have, is to evaluate and improve the prompts that we use for each individual model. And we tend to call this a mega prompt because we have studied different types of documents and different types of issues that we find with the documents, like properly structuring tables, lists, different layouts. So we have been using the SCORE framework to tune the mega prompt, which in principle should allow to do a better work at document processing than using more simple prompts that we have tested already. So with the current evaluation method that we have, we're able to properly rank the different solutions that we propose and offer already tuned prompts that you can use with the different models. And that will be almost everything that I had to say. So if you want to have a closer look at the SCORE framework, we have made it available on Arxiv, as I mentioned before, and you have the link here and as well available in the QR code. So you should be able to get a better idea of what this framework implies, and as well see if this is something that will be beneficial as well for you. And with that, I would like to thank you for your time, and there will be time for questions.
So hopefully everyone enjoyed Antonio's presentation. I'm going to go ahead and read off some of the pre-submitted questions. So the first one is, I'm new to Unstructured, so I'm curious what key capability you bring versus native PDF, Python, OT parsers, OCRs. And then there's a sort of follow-up question to that. What success challenges have you seen with highly technical documentation? So the first question, the capabilities that Unstructured brings is really around the diverse set of files that we support. So unlike some alternatives out there, we support over 65 different file types. So if you are looking for a really scalable solution that supports basically an entire organization's set of documents, that is why you might come to us. As well as we have a managed platform now, so that if you want to just deploy this at scale and don't want to sort of deal with the headache of building your own infrastructure out, that's another reason why people come to us. And in terms of success challenges, we've seen with technical documentation, for plant manuals, which is also listed here, we don't have dedicated sort of I would say parsing sort of algorithms for like the very complex like plant manuals, technical manuals, things of that nature. But our general parsing capabilities do cover a broad set of enterprise documents, including things that have diagrams, figures, things with captions and so forth. But if you're talking about technical schematics, there are more dedicated solutions that handle those. That's probably not best for us. And then, yeah, I guess if Antonio, you want to add anything to that, the key capabilities that we offer in terms of, under the hood with our partitioning and processing pipelines.
Yeah, so just reinforce what I mentioned before, that we have done quite a thorough study of different document types. So people using our system should get a good quality output.
All right, and the next question is, why are you using Tesseract when there are so much better OCR libraries like Paddle? Antonio, do you want to handle that one?
Yes, so we have tested different OCR solutions, and Tesseract is one of them. So either if you're using open source or our platform, there are different options for OCR, and Paddle is included within those. One thing that we've seen, even if Tesseract might not be the best in all cases, and probably it might be the default in some areas. It covers a broader range of languages, which might be relevant to several scenarios, but definitely we support a broad range of OCR systems, and they can be defined either on the open source or platform.
Okay. For teams already using tools like Unstructured, Docklane, or MinerU in pipelines, how difficult is it to integrate score evaluations into CI/CD or automated quality monitoring setups? Antonio?
Yes. So as I've been presenting, the metric is that, well, the framework that we propose is an extension of current metrics. So if you already have a system that is using standard metrics, it should not take long to set that up. The other thing I want to mention is that we have our own evaluation site on our side that relies as well on CI/CD. So it's perfectly possible to integrate it into a CI/CD environment.
What is the best way to embed visual information like pictures with instructions or visual instruction manuals, for example? How do you evaluate reg applications? Is there a continuous metric that we can monitor for performance? So there's a few questions there. So the first one is what is the best way to embed visual information like pictures or visual instruction manuals? So we actually offer a large variety of enrichments in our platform as well. And so things like images within a document, you would typically take those through our enrichment pipeline to do image to text. And so we basically send that to a vision language model, and it basically captures the sort of key essence of that you can then use later to index on for your retrieval augmented generation applications. So of course, we also offered that as a base 64 encoded image as well. So you can then actually, match on your retrieval application to the description, and then you can actually pull back just that image itself as the base 64, and then you can actually render that in your downstream application. So if you have like a chart or something that you want to visualize, or an image itself with like, complex information, you can actually render that in your downstream application as a result. So, and then the second part of that question is how to evaluate RAG applications. Is there a continuous metric that we can monitor for performance? So this is typically a pretty complex open-ended type of, it's not so like straightforward because there's a lot of different ways to evaluate RAG applications. But like one of the standards that you see is like generating Q&A pairs, question answer pairs from your data. And then you basically evaluate the system on recall is typically the most important metric. And then of course, precision is also important because you don't want too much, you could just retrieve the entire thing and then you get perfect recall, but you obviously want some precision. So it is a bit of a trade-off there. And the next question, how does this tool or solution work with existing cloud providers like Azure? So yeah, our platform can be deployed to any cloud out there. So GCP, Azure, AWS, we have deployment options for each of them, and we also support with each of those all of the or nearly all of the different data sources for basically pulling data from, as well as downstream where you're pushing the data to. So if that's like a reg use case, it's going to be vector databases. So in the case of Azure, it's going to be Azure Blob Storage. We support OneDrive on the upstream side, and then downstream we do support Azure AI Search as well as a few of the other options. And then last question of the pre-submitted here: why most of the LLM why do most of the LLM and agentic AI fail when a user requests for an information embedded in the middle of a large table of a PDF? I'll hand that one over to Antonio.
Yeah, so we've been evaluating different models to deal with tables, and obviously tables is one complex element that takes a bit of time for us to tune. So we have been looking at different models, and there are like more simple solutions that will typically don't work with large tables or complex tables, so they get lost with complex layouts of of tables, but we have been having success with some of the newer models that better than previous older ones. So I would say to give it a try on our platform and see how it works on your side.
Okay, and then we had a few questions in the Q&A as well. It looks like Ajay has already provided some answers there. There's one, how are numerical values from tables processed and stored? Antonio, do you want to?
Yeah, so now in our solution, tables are extracted as HTML. So the the numbers will be kept as they appear in the table in one and will appear in one of the cells in the table. So there's no specific processing, but they should appear as they are in the table. So if there is a dot, there will be a dot, there will be a comma, there will be a comma. If there is a dollar sign, it will be preserved. So there will be no specific change to the numbers. So you should get exactly as they appear in the table, in the document.
Okay, and then last question here, as we're up on time. Can your solution be used to bypass the limited context problem of LLMs for analyzing large amounts of data? The goal is to avoid losing important details. I would say yes, absolutely. Like RAG is definitely designed for that. So if you need very precise RAG to basically avoid butting up against context windows, that's exactly what RAG was designed to do. So of course, the devil is in the details in that you have to really design the system to work for you. So getting like your top K right, having re-rankers and whatnot, sort of involved in the pipeline so that you're getting actually the correct information bubbled up to the top of that context window.
Yeah,
And
and I would like to just to add something quickly in document processing. So we'll obviously, as you've seen, we use LLMs to process documents. So we are already aware of the limits that exist for the context size for each one of these models, and we ensure that we don't go over those limits when processing documents.
thanks, Antonio. And with that, I think we are at time.